Okay, so it's time to take a test over all this stuff, over systems. So I will go ahead and do the odds with you. So do the odds with me on the video, and then I'll leave the evens for you to practice yourself. So it all started out with two equations and two unknowns, and when we graph those, they should cross at a common spot. So on the very first one, all we need to be able to do, first of all, is graph these things. So I'll take this one right here and get it started. So I'll just solve that for y, I guess. So how about negative 3y equals 6x plus 12? Okay, so I'll divide both sides, everything by negative 3. So we have y equals negative 2x minus 4. So that one's crossing at negative 4. My pen's not working so good here. Okay, so starts at negative 4, so right about there, and has a slope of negative 2 over 1. So I'll go up 2 and left 1. So up 2, left 1, something right about there. So we have a line, up 2, left 1. All right. And then do the same thing for the other one. So the other one is, let's see here, I've got 4y. I'll take the x and put to the other side, and the 12 to put to the other side. So that's negative x plus 12. Divide off the 4. So we have y equals negative 1/4 x plus 3. So that one starts at the 3. Oh, I'll go, I don't know what, down 1 over 4. Something right there, or up 1, 1, 2, 3, 4 this way. So it looks like they are intersecting right there. So that will be the solution where those two intersect. So where's that intersecting at? Negative 4, 4. And with the whole idea here was we could take this negative 4, 4 and put it in this equation and it'll make it true, and put it in this equation and it will make it true. And if you take a second to do that, it makes them both true. So negative 4, 4 is solution there. Now going down to number 3 and number 5, you'll see that it's exactly the same problem. So 3, 5, and 7 and 9, they all have the same answer. So down below, we should get negative 4, 4 for all of these. The point is to do them all in different methods. So here, the very first method, the point of the first one was to solve it graphically. So one way we could get negative 4, 4 is to graph them and see where they intersect. Okay, now we're going to solve it by substitution. So I know some of you have a hard time with this, that, well, we know the answer is negative 4, 4. The point is not the answer. Negative 4, 4 is the answer. The point is you have to show me enough work that allows me to see that you can do it by substitution. So question number 3, we should get negative 4, 4, but we need to be able to show that we can do it by substitution. So substitution means we're going to solve one of these things. When I take a look at this, I see that that x right there is already by itself. So if I just move those two to the other side, this one will be solved for x. So that's the first thing I'm going to do. So really that is x equals, and then if I move the 4y over there, it will be negative 4y. And if I move the 12 over there, it will be plus 12. Okay, so the idea is now I can take this x and put it in the other equation's x. Okay, so over here then I will have 6 times x, but now we know what x is. X is something else. It's negative 4y plus 12. And then now I have this plus 12 equals negative 3y. Okay, so if I multiply this in there, I've got negative 24y. 6 times 12 is 72 plus 12 equals negative 3y. Okay, so I'll put these two together at least. So 72 plus 12, 82, 84. And then I'm going to add 24y to both sides. So 84 equals negative 3y plus 24y is 21y. Divide off the 21. 84 divided by 21 is 4. So there's the y. Now I'm going to take that 4 and plug it right back in to there. So that is going to make x equals negative 4 times y, which we just said is 4, and then plus 12. So the x is negative 16 plus 12. So x is negative 4. So sure enough, just like we knew the answer was going to be, here we got negative 4 for x and negative 4, or positive 4, I mean, for y. But this time we did it by substitution. Okay, number 5, elimination. Okay, I've got 6x plus, so now I'm going to take these and organize them so that they're in order, x and y, and then the number. So the 6x right there is fine, but I want to move the 3y to the other side, so I'll add the 3y to the other side, and then I'm going to move the 12 by itself as the constant. So I put it in standard form. And then same thing with the bottom one. The x is in the correct spot, the 4y is okay. And then I'll move the 12 to the other side, so that will make it equal to positive 12. Okay, let me clean this negative up a little bit. Okay, so now I would probably make the x term right there go, so if I multiply this one by negative 6x, the x's will go away. So I'm not going to do anything to the top one, so that's just 6x plus 3y equals negative 12. But this one I'm going to multiply everything times negative 6. So negative 6 times x is negative 6x. Negative 6 times 4 will be minus 24y. And negative 6 times 12 will be negative 6672. And I'm going to add those up. So those are 0. 3y minus 24y will be negative 21y, and negative 72 minus negative 12 and negative 72 is negative 84. Divide both sides by negative 21, and sure enough we have y equals 4 again. I can take that 4 and put it really wherever I want. I'm just going to plug it right there for this particular problem. So I've got x plus 4 times my y, which is 4, equals 12. So x plus 16 equals 12. Subtract 16 from both sides, and x is negative 4, just like we knew it was going to be. So our final answer for that one is x is negative 4, y is 4, but this time we did it by elimination. Okay, now in number 7, we want to do the same problem by row echelon matrix form. Okay, so I need to get them lined up basically how I did with number 5 again. So here they are. There it is already in nice clean order. So I'm going to start number 6 like that. So for number 6, row echelon form, that means I need this to happen. I guess I'll stay in blue so you can keep them apart. So that means I've got a 6 and a 3 who has an answer of negative 12. And then I've got a 1 and a 4 who had an answer of positive 12. Okay, so here the whole idea is to get this spot right here a 1. This spot right, this diagonals both need to be a 1. And then we have row echelon form. Okay, well, I'm just going to switch the order because that one's already 1. I want that to be a 1 first. So right off the bat, I'm just going to switch the order. So I've got 1, 4 is 12, and then 6, 3 is negative 12. So just a row swap. Okay, now I need this one to be 0. So I'm just going to multiply the top one by -6 and add it to the bottom one. So I'm going to do -6 times row 1, add it to row 2, and put that back into row 2. That's my strategy. Okay, so -6 times this one is -6 plus 6 is 0. Well, first I'm going to rewrite the top because nothing's happening to the top. But then that one becomes a 0. Then I need -6 times 4 plus 3. So -6 times 4, -24 plus 3 makes this a -21. And then I need this one times -6 plus this one. So -6 times 12, -72 plus -12, so -84. Now technically we could stop right here because right here's one of the answers, but I just want to keep going, get it to row echelon form. So I'm going to go ahead and finish out this diagonal to be a 1. So in order to do that, I'm just going to take row 2 and divide it by -21, and that'll make it a 1, and put that back into row 2. Okay, so row 1's going to stay the same, 1, 4, 12. Taking this one, dividing it by 21 is still 0. Taking this one and dividing it by -21 is now 1, like I want it. And taking this one divided by -21 is +4. All right, and then technically, so again, this is one of the answers right here. See how that says y equals 4? But I want to finish this one. So we could stop right there if we only wanted the answer. But remember, we're not just interested in the answer. We're interested in the process. So I'm going to try to finish this one out. So what that means is I need this to be a 0. So let's take row 2 and multiply it by -4. And add it to row 1 and put that back in row 1. Okay, so I'm going to take row 2, so right here 0 times -4 is still 0, add it to 1, so that's going to be a 1 again, so nothing happened there. Now I'm going to take this one, multiply it by -4, so that'll be -4, add it to this 4, so that will be 0. Now I'm going to take this row 2 times -4, so that'll be -16, add it to this one, so -16 plus 12 is -4. And then the bottom row we didn't do anything to. Okay, this is called row echelon form because now remember these were the x's and these were the y's. So this one right here is saying 1x equals -4. Oops. Equals. And then right here that's saying y equals +4. So just like we knew the answer was going to be from the problems previously, we got x is -4 and we got y is 4, but we did it by row echelon form. Okay, and now number 7 wants to do it yet, we're up on to number 9, Kramer's rule. Okay, so now we want to be able to do this with Kramer's rule right here. Okay, Kramer's rule says that the x answer is dx divided by d, and the y answer is dy divided by d. Okay, so let's take a look at what all that means for number 7. So same thing, I still need to get it in standard form. So let me rewrite it down here where we can see that. So I've got 6x plus 3y equals -12, and then the other one was x plus 4y equals positive 12. Okay, so let's get the determinant first. So D, here's D. It's 6, 1, 3, 4. The determinant is these two minus these two. So AD minus BC. So the determinant is going to be 6 times 4 minus 3 times 1. So D is 21. Okay, dx. Now we just take the answer, we take the answer column and put it into the x column instead. So instead of 6, 1, it's going to be negative 12, 12. And then the other one is the same. And we find the determinant of that. So it's this diagonal minus this diagonal. So negative 12 times 4, negative 12 times 4 is negative 48 minus 12 times 3. So negative 48 minus 36 is negative 84. Okay, then for dy. I'm going to replace the y column with the answers, so I'll put negative 12 and 12 in there this time. So dy is going to be 6, 1, negative 12, and 12. So we have 6 times 12 minus this, so that's going to be 72 minus negative 12. So 6 times 12 is 72 minus negative 12, so 72 plus 12 is 84. Okay, so here comes our answers then. So x is dx, which is negative 84 over d21, which is negative 4. And y is dy, which was positive 84 over 21, which is positive 4. And there's our answer set again, negative 4, 4. Only this time we did it by Kramer's rule. See, isn't it cool that we can get the same answer 5 different ways? We started all this off up here by graphing, then we did it by substitution, then we did it by elimination, then we did it by row echelon form, and now we've done it by Kramer's rule. And all the different ways end up with the answers solution set negative 4, 4. Okay, let's take a look at number 11. Okay, here's number 11. It says do it without a matrix, so that means solve it by hand. So let's see here. I would probably at the beginning go for the y's, right? There's a 3y and there's a 3y. So I'm just going to take the first row and subtract it from the second row. In fact, maybe I'll just change all the signs. I'll make that positive, make that negative, and that negative, and that positive. And I'm just going to take those two and add them together. Okay, so we've got a negative 3x plus a 2x, so that'll be a negative x. And then I've got a 3y plus a negative 3y, that's gone. So now I've got a 4z plus a negative 5z, so it'll be a negative 1z. And then lastly, we've got a 4 plus a 3 for 7. Okay, so I took equation 1 plus equation 3, only I negated it, and that got rid of the y. So I need any 2 other equations and get rid of the y again. So I think I'll just take the top 2 right there. All right, so there's negative 3x plus 3y plus 4z equals 4. But now I'm going to negative triple this one. So I'm going to multiply everybody times negative 3 right there. So negative 5 times negative 3 is positive 15x. Negative 3 times y is negative 3y for that piece. And negative 3 times this one will be negative 15z. And negative 3 times this one will be positive 27. Now I'll add those up. So That becomes 12x. Those are 0. This becomes negative 11x, or z, I mean, and these will add up to 31. Okay, so here I have an equation just with x's and z's, and here I have an equation just with x's and z's. I think I'll try to get rid of, how about the z, since 11 is easy to multiply by. So I'm going to multiply all of this times 11. In fact, I'm going to multiply it times negative 11. So I'm going to multiply this times negative 11 times this whole thing. So negative 11 times negative x will be 11x. Negative 11 times negative z will be positive 11z. And negative 11 times 7 will be negative 77. Now I'll add these together. So 12 plus 11 is 23x. The z's go away. And negative 31 minus 77 is negative 46. So dividing everybody by 23, we got x equals negative 2. Okay, I'll just pick this one right there. That looks like a good place for the x to be. So negative 2 minus z equals 7. So I've got 2 minus z equals 7. Move the 2 to the other side, so negative z equals 5. So z equals negative 5. And I'll just pick any equation to put them both into. So I think I'll just pick the very top one. So we've got negative 3 times x plus 3 times y plus 4 times z, which is negative 5, equals 4. Okay, so negative 3 times negative 2 is 6 plus 3y. Negative 5 times 4 is negative 20 equals 4. So I'll put the 6 and the 20 together. So I have 3y minus 14 equals 4. Add 14 to both sides. So 3y, 4 plus 14 is 18. Divide off the 3, so y is 6. So there's our answer set for that one. X is negative 2. Y is 6. Z is negative 5. So we did it without a matrix. So if we did that one with a matrix, we would expect to get the same thing. Okay, number 13, we can use a matrix in any way we want. That means we could use Kramer's rule, we can use row echelon, we can do whatever we want. So I'm going to do row echelon only part way. So let's see here. Let's put this in a matrix. So we've got 1, oops, I'd like a black pen. Okay, so I've got 1, negative 6, and negative 15. 2, 3, negative 2, negative 5. And negative 4, negative 3, negative 2, and 13. Now, I really like Kramer's rule, but that means we got to get the determinant of this 3 by 3, and that seems to be a little bit more work. So I'm just going to try to get a diagonal of 1s right here. Really, I just need to get down to that one to be a 1 and call it good. Okay, so I've already got that one a 1, so now let's just work on this 2 right here. So that should be pretty straightforward. How about we take negative 2 times row 1 and add row 2. And put that in row 2. So I'm not going to do anything to the top one. So I've got 1, negative 6, answer of negative 15. Okay, but now row 2, I'm going to take negative 2 plus this one, so that will be 0. Negative 2 times this is 2 plus 3, so that one will become a 5. Negative 2 times this is 12 plus negative 2, so that will be 10. And negative 2 here is 30 plus negative 5, so positive 25. And then the last row didn't do anything. Okay, so now I want to get this one to be a 0, so I think I'll multiply this times 4 and add it to that. So I'm going to do 4 times row 1 and add it to row 3 and replace that in row 3. Okay, so row 1's not changing. So I have 1, negative 6 at negative 15. Row 2 is not changing. 0, 5, 10, 25. And now row 3, I'm taking this one times, so that's 4, plus this one is 0. Okay, now I'm going to take this times 4, so negative 4 plus negative 3. So negative 4 plus negative 3 will be negative 7. I want to take this one times 4, so negative 24 plus negative 2 will be negative 26. And lastly, this one times 4, so negative 60 plus 13, so negative 60, negative 47. Okay, so we got zeros under this one. The next thing we do is get this a 1 and get zeros under that. That's going to be easy to get a 1 just by dividing it by 5. So I'm going to divide row 2 by 5. All right, that should be easy. Row 1 doesn't change. 1, negative 1, negative 6, negative 15. So row 2, 0 divided by 5 is 0. 5 divided by 5 is 1. 10 divided by 5 is 2. And 25 divided by 5 is 5. That turned out pretty nice. And row 3, nothing's happening to row 3. Okay, so I got a 1 in that diagonal, a 1 in that diagonal. Now I need a 0 under this one. So I'm just going to multiply row 2 times 7 and add it to row 3. And put that into row 3. Okay, row 1's not changing. So over here on row 1, I've got a 1, negative 6, 15. Row 2's not changing. 0, 1, 2, 5. Okay, row 3, I'm taking 7 times row 2, so 0, plus row 3, 0. So that one is still 0. Okay, then I want to take 7 times row 2, so that'll be 7, plus negative 7, so that will be 0. Okay, I need 7 times row 2, so 14 plus negative 26. 14 plus negative 26, what do we have there? Negative 12. And 7 times this will be 35. So 35 plus negative 47 is a negative 12. Okay, we don't really need to go any further. We could, technically we want to get all of these diagonals to be a 1, so we could just divide this row by negative 12 and we have 1s everywhere. But we don't even really have to do that, because right here's what we remember. This is the x, this is the y, and this is the z, and these are the last column are the solutions. So negative 12z equals negative 12, so there we have z is 1. I can plug that back up in here because that just said this says y plus 2z, which is now 1, equals 5. So subtract the 2 from the other side. So we have y is 3. And now this one up there says x minus y minus 6z equals 15, and substitute those in there. So x minus the y, which is 3, minus 6 times z, which is 1. So we have x minus 3 minus 6 equals 15. So x minus 9 equals 15. And when I look up here, I see I forgot that negative on that 15 right there. That's actually negative 15 all along here. So negative 15, negative 15. So when I add 9 to both sides, we have x equals negative 6. So there's our solution set for that. x is negative 6, y is 3, and z is 1. Okay, let's go look at number 15. Special cases. So, of course, there's no solutions and there's all solutions sometimes on these, or there's infinite solutions. So let's take a look at number 15. Solve without a matrix. So no matrix here. So let's see what happens when we're not using a matrix and all of this stuff happens. Okay, I wonder if I can squeeze it right in there. Probably I would try to eliminate the y's. I can just take this one times 2 right here. So I'm going to double this one. I'm going to multiply it by negative 2. So let me see. Negative 2 times 15 makes that positive 30x. Negative 2 times 12 makes that minus 24y. Negative 2 times 24 makes that negative 48. And then I'll multiply this one times 3 because I'm trying to eliminate the y. So negative 30x plus 24y, and 3 times 22 makes that 66. So I was trying to eliminate those, which I got those to be 0, but see what happened? 30 minus 30 is also 0. So this whole side ends up being 0, and this side ends up being whatever that is, 18. And since that is false, this has got no solutions. So had this been true, if it would have been 0 equals 0 or 18 equals 18 or something like that, then it would have been infinite solutions. But it ended up being false, so that's no solutions. So let's take a look at a no solution one. I think 17 then is also no solution. So let's see what happens when we have 3 of them to deal with. Okay, so trying to do this with no matrix. Oh, I don't know. Maybe I'll try to get rid of the r's. I'll just take this one right here. Whoops. I'll take this one right here and take it times 2. Okay, so doubling that one, we have 2r minus 2s minus 2t equals 10. And I'll just put it with this one right underneath it. So negative 2r, that's what I was going for, plus s plus 2t equals negative 15. Okay, adding those up, those make 0. These make negative 1s. These make 0. And adding these up, we get negative 5. So there's one of the answers, s equals 5. Well, if we already have a variable solved here, I'm just going to go put that back in these two and see what we've got again. So if s is 5, that's really r minus 5 minus t equals 5. And if s is 5 here, that's really negative 2r minus or plus 5 plus 2t equals negative 15. I'll take this 5 and put it to the other side. So adding 5, that's r minus t equals 10. And I'll take this 5 and put it to the other side. So that's negative 2r minus 2, it was plus 2t equals negative 15, so negative 20. Okay, now I'll try to eliminate that one. It looks like if I just double this one again, I can get rid of the r's again, I guess. So, okay, so here I've got 2r minus 2t equals 10. And down here I've got negative 2r plus 2t equals negative 20. So those add up to 0, those add up to 0. So I've got 0 equals negative 10. And again, somewhere along the process, I ended up with something that's false. And anytime you get to something that's false, there's no solutions. It may not happen at the beginning. I started to get a partial answer, but that partial answer then led it into being false. So anytime we have something false, there's no solutions. Okay, 19. Okay, 19 wants to know what the special case looks like with a matrix. So using a matrix, what does no solution and all solutions look like? Well, let's take a look. So for 19, I'll make a quick matrix here. So I've got 4, negative 3 gives an answer of negative 11, and 8 with negative 6 gives an answer of negative 22. Okay. So for a matrix, we typically want we want this one to be a 1 right there. So I'm just going to divide that top by 4. I'm going to divide everybody on the top by 4. So that makes that 4 divided by 4 is 1. Negative 3 divided by 4. Negative 11 divided by 4. Okay, so there they are so far. Then I would want this one to go away, so I'll take the top one times negative 8. So I'm going to go negative 8 times row 1 and add it to row 2. Put that into row 2. Okay, so row 1's not changing, so I've got 1 negative 3/4 and negative 11/4. Okay, then I'm doing negative 8 times this, so negative 8 plus 8. Okay, that's 0. Negative 8 times this. So if I just go over to the side, I got negative 3/4 times negative 8. Those cancel out. So it looks like to me it is positive 6. And then I need negative 8 times this one plus negative 22. Oops, what happened here? I got the negative 6 out of this, but I forgot to add it to that. I got the 6 out of this, but I forgot to add it to negative 6. So 6 plus negative 6 makes this one actually right here 0. And then the last one I need to do now is negative 8 times this plus negative 22. Okay, going on to the side then, I've got negative 11/4 times negative 8. So it looks like that becomes positive 22. So positive 22 plus negative 22 makes this one 0. Okay, so look what we've got right here. We ended up with some of the variables dropping out. So on this side we have 0, on this side we have 0. We have 0 equals 0. That is true. That means this one has infinite solutions. So whenever the variables drop out and it's false, it's no solutions. When the variables drop out and it's true, it's infinite solutions. Let's take a look at that happening with number 21. Okay, 21 for a matrix. I've got negative 2, negative 5, negative 3, answer 7, negative 3, negative 5, negative 2, answer negative 15, a 2, a 3, a 1, and a negative 6. Okay, I need that to be a 1. So at first glance, I could just divide all this by negative 2. That would be okay, but then I'd have some fractions. I might try to do it without that fraction right off the bat. So I think just to keep myself straight, I'm going to put this one at the top and this one second. Only because I see there's a difference of 1 right there. So I think I can get a 1 out of this. But I'm just so I don't lose anything, I'm going to reorder them here. So I'm going to put the bottom row on top. So I've got 2, 3, 1 at negative 6. Then I'll put the negative 3, negative 5, negative 2, and negative 15 here, and then the negative 2, negative 5, negative 3, this is row 1, negative 3, and 7. Okay, so all I'm going to do is take row 1 and add it to row 2 and put that one in row 1. I'm going to add those together and put it back up here, and that'll give me a 1 right there. It'll give me a negative 1, but I'll fix that in just a second. So I want row 1 plus row 2. So 2 plus negative 3 is negative 1. 3 plus negative 5 is negative 2. 1 plus negative 2 is negative 1. And 6 plus negative 6 plus negative 15 is negative 21. Okay, and then the other ones didn't change, so we've got -3, -5, -2, and -15, and then -2, -5, -3, and 7. And I want this one right here to be a positive one, so I'm going to go ahead and multiply everybody by a negative, so that's going to make that positive, make that positive, make that positive, and that one positive. And now I've got it. I've got my first part of the diagonal is a +1. Now I need that to be a 0. So now everything should be easy. Once we get a 1 up at the top, I'll take 3 times row 1 and add it to row 2 and put that back into row 2. So 3 times 1 is 3 plus -3 makes that one 0. Oops, I should not do that next. Let me put the row 1 in there first. So I've got a 1, a 2, 1 at 21. Now let's do it. 3 times this one plus this one is 0. 3 times this one is 6 plus -5 is 1. 3 times this one is 3 plus -2 is 1. And 3 times this one is 3 times 21 would be 63 plus -15, so 48. And then I've got a -2, -5, -3, and 7 down there. Okay, I want this one to be 0 next. So how about I just, this times 2 plus that one. So I'm going to go 2 times row 1 plus row 3 into row 3. Okay, 1's not changing. So 1, 2, 1, 21, 0, 1, 1, 48. And now let's apply our little test right here, our little rule. 2 times this one is 2 plus this one is 0. 2 times this one is 4 plus -5 is -1. 2 times this one is 2 plus -3 is -1. And 2 times this one is, what do we have here? 2 times this would be 42. 42 plus 7 would be 49. Okay. Now I need this to be 0. So I just can take this one times 2. No, I'll just add these two together. I don't even need to do any. So I'm going to take row 2 plus row 3 and put it into row 3. Okay, 1, 2, 1, still 21. 0, 1, 1, still 48. So now I'll apply the rule. I'm taking this one plus this one. So 0 plus 0 is 0. 1 plus -1, 0. 1 plus -1, 0. 48 plus 49, 97. And right here's what's false. Right there we have 0 equals 97 because all the variables went away. That is false. Therefore, no solutions. As soon as we get something false, it's no solution. And that's number 21. Number 23, some simple matrix manipulation. Adding, you just take the first spot plus the first spot equals the first spot plus the first spot plus the first spot. So here we have 0 plus 6 plus 0. So this is here's number 23. 0 plus 6 plus 0 is 6. Second position, 0 plus 4 plus 6 is 10. Third position, 4 plus -6 is -2 plus 1. Excuse me, is -1. And then the fourth position, 1 plus -6 is -5 plus 0. And that's really, addition is really easy. 25, this is called scalar multiplication. So 25, when it's not a matrix times a matrix, you just take this 3 and dump it in there. So it's 3 times all of them, and that's literally all it is. So 25, 3 times -1, that first spot's -3. -4 times 3 is -12. -2 times 3 is -6, and 6 times 3 is 18. So you just multiply them all. You do have to do order of operations on number 27, so we've got to do the parentheses first, so we'll add those first. So that's going to make a matrix of 0 plus 2 is 2, and 6 plus 3 is 9. So really, it's 3 times that. So 3 times that is, 3 times 2 is 6, 3 times 9 is 18. So there's that matrix. Now, matrix multiplication is different. A matrix times a matrix now. We got to first of all see if it works. D-O, the word do, that means down and over. So down, going down, this is 2, and going over, it's a 2. So that's a 2 by 2, and this one going down is a 2, and going over is a 3. Now, these inside numbers have to be the same or else it's undefined. So check, this is going to work. If it's going to work, then this is the answer. So the answer is going to be 2 down and 3 across. That's what the answer is going to look like. The answer is going to be a 2 by 3. All right, to get this spot right there, it's the first row across and it's the first column down. So we're going to take the first row across, those, and those. So it's -5 times 2. That's the 5 and the 2 plus the -4 times the -5. So we did those 2 times those 2. So -5 times 2, and then the -4 times -5. So that ends up to be, what do we have here? -10 plus 20. So a 10 is in that first spot. Okay, I'll do the next one, and I'll do this one across and that one. So now I'm going to go across the top but down the middle. So it's going to be -5 times -5 times -4. So that's -20. And then -4 times -5. So another -20. Oh, no, that's a +20. So I better do that again. -5 times -4 is +20. And then -4 times -5 is another +20. So 20 plus 20 makes that one 40. Now to get this one, I'll go across and then the third one. So -5 times 4, that's 20. And then -4 times 4 is -16. So 20 plus -16 is 4. Now I'll do the bottom one times the bottom row times the first column. So that's these, the 6 and the -2. So 6 times 2 is 12, plus -2 times -5 is 10. So 12 plus 10 is 22. And to get this one, I'll go to the middle column. So it's the 6 and the 2 with the -4 and the -5. So 6 times -4, -24, plus -2 times -5 is 10 for -14. And then the last one will be this way and this way. So the 6 and 2 with the 4 and the 4. So 6 times 4 is 24. And then -2 and 4 is -8. So 24 minus 8 is 16. So there's our answer. I'll clean it up here just a little bit. So what do we have here? 10, 40, 4, 22, -14, and 16. That's how you do matrix multiplication. And let me go back and check this one. I don't think I have this one right here, right? That 4 right there. That came from across and down right here. So that should have been the -5 times 4. That should have been -20 right here. And then -4 times 4, -16. So that actually should have been -36. Okay, there we go. '31, we've got to do order of operations here. So when we take a quick glance, we've got some parentheses right there. So let me do the parentheses first. So I need to go ahead and add those up. So I've got 2 plus 0, so that's just 2. -1 plus -3 will be -4. -1 plus 4 will be 3. And 5 plus 3 will be 8. So I'm trying to take that matrix now. So there's the parentheses times this matrix, 5, 3, 0, 1. Okay, so this one over here is a 2 by 2. This one over here is a 2 by 2. Sure enough, the insides are the same, so the outsides will be that answer, which is a 2 by 2. So this one's going to have an answer of 2 by 2. Okay, to get this first spot right up there, I need across times down. Okay, so 2 times 5 is 10 plus -4 times 0. So that first spot is a 10. All right, let's go for this spot right here. So I need over the top and then down the side, this one. So 2 times 3 is 6. Let me get a different color. 2 times 3 is 6 plus -4 times 1 is -4. So 6 plus -4 makes that one 2. Let's go for this one right here. Okay, so that's going to be this one and this column. So 3 times 5 is 15, plus 8 times 0 is 0. So 15 plus 0 makes that one a 15. And then the last one will go here times here. So 3 times 3 is 9, plus 8 times 1 is 8 for a grand total of 17. So for 23, to do order of operations, we will do the multiplication first. So this is a 2 by 2. I mean for 33. This is a 2 by 2, and we want to take that by 2 down and 3 across. Okay, so these are going to work because the insides are the same. So it's going to end up being a 2 by 3. So 2 down and 3 across. Okay, let's get this first one right here. So that's going to be over in this way. So 0 times, so it's going to be 0 times -2 is 0 plus 2 times 4 is 8. So 0 plus 8 is 8. To get the next one, it's going to be 0 times 6. So I'm going to do this column. 0 times 6 is 0, plus 2 times 0 is 0. So 0 plus 0 is 0. And then I'll do this column. So going across, so I've got 0 times -4 is 0, plus 2 times 6 is 12. Okay, going again, next one down. So now I'll do these. So I've got 2 times -2, that's -4 plus, so -4. And then I've got a -3 times 4, so -12. -4 plus -12, -16. Then I'll do the middle column with that one. So 2 times 6 is 12 plus 3 times 0, so that's just 12. 2 times -4 is -8 plus -3 times 6 is -18. For -26. Okay, so there's the multiplication, and now I need to subtract this. Okay, so I need to take all of that, subtract to -1. Okay, well those will not work. You can't, addition and subtraction has to have the exact same size. A 2 by 3 can only subtract another 2 by 3. So we did all of that work, and then the subtraction doesn't work. So this one's undefined. Undefined. Those will not go together. 35, evaluate the determinant of each matrix by the standard method. Okay, so again, here we have the method matters. Here we're going to do the standard method. Here we're going to do the diagonal method. So when it asks for the standard method, you got to do it that way. You can't take the shortcut as the diagonal method. Okay, so let's remind ourselves how to do 35. All right, the standard method is to take each of these three times their mini matrix. Okay, so what that means is I'm going to take this -1 times its mini matrix. So it's -1 times that. All right. So -1 times the determinant of 2, 2, 1, 3. Now, the other thing that we got to remember is that that one stays the same, but this one gets negated and that one stays the same. So the next piece is going to be a negative of that one. So I'm going to say minus, and now I'm going to go, let me get an eraser here. So now I'm going to go this one, so -5, and get rid of its diagonal and column, row and column for its mini matrix. So it's minus -5 times the determinant -1, 2, 2, 3. And then I've got this plus right here. So then the next piece will be plus. I'll put that right here somewhere. The -1. So now I'm going to take this one and get rid of its row and column. So it's going to be plus -1 times its determinant of -1, 2, 2, 1. Okay, that's the determinant of the overall thing. So the black part, let's take a look at the black one up here. So remember how to do these determinants. It's these two minus these two, so 6 minus 2. So up here, I've got -1 times 6 minus 2. Okay. The red part, minus makes plus 5 times -3 minus 4, so -7. And the blue part will be -1 times, right here is -1 minus 4, so -5. So let's see what we've got. So right here we've got -1 times 4. Here we've got minus 35. Here I've got plus 5. So we've got -4 minus 35 plus 5. -34 is that determinant. Okay, 37 is to do it by the diagonal method. Okay, the diagonal method, we've got -4. Actually, I think I'll just put it over here. I'm going to add a -4. Let's see if we can make that a little bit bigger. 3, a 2, and then a 3, 2, -4. I just took these two columns and extended it. Okay, the reason I want to do that is because now I want the diagonals going down. So I want that diagonal, and that diagonal. Okay, -4 times -4 is 16 times 2. So that one, 16 times, positive 16 times 2 is 32. Plus these. 3 times 2 is 6 times 2 is 12. And then these. 5 times -5, -4 is positive 20 times 3, so 60. So there's the positives. Now I want to subtract these. Oops. Okay, so I'm going to subtract those. So there's 2 times 2 is 4 times -5. 4 times -5 is -20. So I want to subtract -20. Subtract the next ones. -4 times -4 is 16 times 2. So I'm going to subtract 32. Subtract, and then the last one right here, 3 times 3 is 9 times negative 4, so negative 36. I want to subtract negative 36. Okay, so that's going to make this plus 20 and plus 36 for a grand total of 128. The determinant of that one is 128. Okay, 39, we want the inverse now of a matrix. So the inverse of a 2 by 2 is 1 over the determinant. And then, remember, this is A, B, C, and D. Well, D and A change places, and then B and C get negated. Okay, so first we need this part. We need the determinant part. Okay, well, that's just these two minus these two. So negative 22 minus 0. So the determinant of this thing, negative 22 minus 0 is negative 22. Okay, so it really is it's that simple now. So it's 1 over negative 22 times the matrix. So D and A will get switched. So the 11 and the negative 2 will get switched places. So 11 and negative 2. And then the B and C are negated, so negative 9 and negative 0. Now, you can actually answer it like that, or you can multiply in the negative 1 over 22. So we have really, I'll go ahead and do that. So it'll be negative 11 over 22, so that's negative 1/2. Negative 9 over negative 22, so 9 over 22, 0 over 22, and negative 2 over 22 would be positive 1/11. There it is multiplied in. Okay, taking the inverse of a 3 by 3 is a lot of work. So these are not that much fun, and you got to keep a lot of things straight. So let's get started on this one. So first we need to know the determinant. So first I need this. Okay, well, we have two ways to do it. We did them earlier. I'm going to do the diagonal method because I think it's faster. So negative 2, negative 5, 1, 4, 3, 1. And I need these diagonals. The blue ones are going to be the positive ones. Okay, so negative 2 times 3 times negative 5. So that'd be 2 times 5 is 10 times, so that's 30. Plus 4 times 3 is 12 times 1, so that's 12. And then 4 times negative 5, that's negative 20 times 1, so that's negative 20. Okay, now I need these diagonals. They're going to be all the negative ones, so I need to take all of these and subtract them. So 1 times 3 times 4 is 12, so negative 12. 1 times 3 times negative 2, that's negative 6, so minus negative 6. And then we have negative 5 times negative 5 is 25 times 4 is positive 100, so minus 100. Okay, let's add all that up. The whole thing is negative 84, so the determinant of all that is negative 84. Okay, that's the easy part. Now, we need the matrix of mini matrices. So let me get rid of all this again. All right, I'm going to slide this over. I'll remember the determinant is negative 84. I need some more room here. Okay. So here's the idea. I'm going to start with this one, take out those, and have that matrix. Okay. Then I'm going to do this one, take out those, and have this matrix left, the negative 5, that as the mini matrix. Okay, then I'll start with this one and take those out and have this as the mini matrix. That would be 3 of them. Then I'll do this one, take out that row and column, and have this as the mini matrix. 4 of them. And then I'll do this one, this way, and have that as the mini matrix. That'd be the 5th one. and then the 4, take out the 4 and have that mini matrix, and so on and so on, and then take out the 1, have that as the mini matrix, take out that 1, have that left over as the mini matrix, and take out the 5 and have that left as the mini matrix. So there's 9 mini matrices in there. Okay, I need to get them all. And while I'm at it, this is something that people were forgetting. This one will be positive, this one will be negative, positive, negative, positive, negative, positive, negative, positive. So then they also alternate signs when we do this. Okay, so I'm just going to start with the 2's mini matrix. So here we go. If I take out the 2, that leaves me 3, 3, 1, negative 5. 3, 3, 1, negative 5. Okay, now I'm going to take out the 4. That leaves me negative 5, 3, 1, negative 5. Now I'll take out the other 4. That leaves negative 5, 3, 1, 1. I got to go do it for the second row. So now I'm going to take out the 5. Take out that one. So that's going to leave 4, 4, 1, negative 5. Now I'm going to take out the 3. That leaves negative 2, 4, 1, negative 5. Now I'm going to take out this 3 right there. That row and column leaves negative 2, 4, 1, and 1. And the last one down here, take out the 1. It's going to leave 4, 4, 3, 3. So taking out this 1 right there, it's going to leave negative 2, 4, negative 5, 3. And then the last one, taking out the negative 5, leaves negative 2, 4, negative 5, 3. Okay, let's see what we've got here. All right here I got negative 15 minus 3. Negative 15 minus 3, negative 18. Here I've got 25 minus 3, so 22. Here I've got negative 5 minus 3, so negative 8. Here I've got negative 20 minus 4, so negative 24. Here I've got 10 minus 4. Here I've got negative 2 minus 4, negative 6. Here I've got 12 minus 12, okay, an easy one, 0. Here I've got negative 6 minus negative 20, so negative 6 plus 20. And here I've got negative 6 minus, okay, the same one. Negative 6 plus 20. But now remember, they came plus, so that one's okay. So this one's minus, plus, minus, that one changes sign, so that's a plus 24. Plus, minus, so that's a positive 6. Plus, minus, so that's a minus 14. Plus. Okay, so really what we've got, let me clean that up a little bit. So this is a, well, listen. This is a positive 24. This is a positive 6. Okay, there we go. Okay, so the matrix now, it's the determinant, which was 1 over, it's 1 over the determinant, so it's 1. The determinant from way back at the beginning was up here at negative 84. So we have 1 over 84. 1 over negative 84 times the matrix. Now, it's not just this. Now we've got to take, we've got to switch the rows and the columns. So that row is going to become this column. the middle row will be the middle column, and the third row will be the third column. So we've got to get it in there like that. So the red one is negative 18. Oops. So negative 18, negative 22, negative 8. The next one, 24, the blue one, so coming down, so we got 24 and then 6 and 6. And then the green one was 0, negative 14, and 14. So getting a matrix of a 3 by 3 is a pretty big hassle. Now, you could multiply in the negative 84, 1 over 84, but I'm not going to. I'm just going to leave it like that. Okay, that's number 41. Let's take a look at 43. Why do we need that? Because this is the inverse, and algebra does inverses. So up here at 43, we want to do the inverse of some of these things. 43 is going to be easy because the inverses of are easy. The inverse of addition is subtraction, so I'm just going to subtract the matrix 4, 5. Okay, well that's easy. Subtracting 4, 5, that's nothing. So we have 4 times some matrix. Remember that capital letter X means there's a matrix there, equals now this little matrix. 40 subtract 4 is 36. And negative 19 subtract 5 will be negative 24. So there we have it so far. And now this is scalar multiplication right here. That's the number 4 times a matrix. Well, that's just multiplication. That's regular multiplication. And the inverse of multiplication is division. So I'm just going to divide by 4 and divide this one over here by 4. So those are gone. And our resulting matrix X, the matrix X is 36 divided by 4 was 9, and negative 24 divided by 4 was negative 6. So the missing matrix that would have made all of that work was 9, negative 6. So that's pretty easy. That's just algebra. But down here at 45, it's this piece right here. See, now I've got a matrix times a matrix. I've got to inverse this matrix off, which is why we learned how to do all of this inverse stuff. So let's see if we can't get this one. Well, that's not the first thing that we would do anyway. So first of all, let's fix this piece. How about I just subtract this matrix from both sides? I'll subtract that matrix over here also. So I'm going to subtract the 9, negative 3, negative 4, and negative 5. So I've got negative 7, subtract negative 9, so negative 16. 9 subtract negative 3, so 12. Negative 15 subtract negative 4, so negative 15 plus 4, negative 11. And negative 2 subtract negative 5, so negative 2 plus 5, 3. Okay, now I have this negative right here, so it's equal to negative whatever, all of that, negative 2, negative 2, negative 1, negative 2, times some matrix they're calling A. Okay, well, I'm going to divide both sides by negative 1 still, so I can get rid of this negative right there. So it makes that positive. Positive, positive, negative, negative. So really what we have is 16, negative 12, 11, negative 3 equals negative 2, negative 2, negative 1, negative 2 times some matrix they're calling A. And that's what we're trying to find. We're trying to find that matrix right here that when you multiply all of this together, it equals this. Okay. Well, just like we undid a negative, we divided a negative. We undid addition with subtraction. We've been doing the inverse. So we need the inverse of this piece right here. The inverse of this will make it go away, and I'll do the inverse to both sides. So I need the inverse. But the inverse of a 2 by 2 was pretty easy. It's 1 over the determinant, so it's 1 over the determinant of these two minus these two. So that'd be 4 minus 2. So 4 minus 2 is 1/2. 4 minus 2 is 2. And then these two positions get switched. Well, they're both the same number, so -2 and -2, but technically they got switched. And then these two positions get negated, so that's going to become a +2 and a +1. So there's the inverse. I'm going to go ahead and multiply that in. So the inverse of this thing is -2 times 1/2, so -1, 2 times 1/2 is 1, 1 times 1/2 is 1/2, and -2 times 1/2 is -1. Okay, this is the inverse. If I take this times this, they will cancel each other out. They will become the identity matrix, which means they go away. But now remember, these things, order matters. We always do the inverse to the left, so we're going to take the inverse times the original. That means, so that will make this diagonal go away. That means over here we've got to take the inverse times this thing. So what I need for my final answer, so the inverse here will make it cancel out, so I'll have my matrix A equals, over here I need the inverse of -1, 1, 1/2, -1 times 16, -12, 11, and -3. Let's see what we get out of all of that. So it's a 2 by 2 times a 2 by 2, so it's just going to be a 2 by 2. Okay, let's go for this one right here. So this row times this column. So -1 times 16, so -16 plus 1 times 11. I'll go for this one. How about, I'll go this one right here. So -1 times -12 plus 1 times -3. Now come down here. 1/2 times 16 plus -1 times 11. And then the last one, 1/2 times -12 plus -1 times -3. That's equal to our big matrix we're looking for. So our final answer that we should end up with right here is -16 plus 11 is -5, 12 plus -3 is 9, 8 plus -11 is -3, and -6 plus 3 is -3. That matrix right there, if we go all the way back up here and stick it in right there, makes this true. So we take this matrix times what we just found, multiply it by -1, add this one to it, it ends up being that. And after this test, we're going to go and check that, because there's a way to check it that's a little bit faster than doing it all from scratch. So let's just trust ourselves. We have it correct. This would end up solving all of that.